So, and now we have discussion about another coordinate system. So, cylindrical coordinate system. So, already you are familiar about the cylinder. Okay, what are the cylindrical shape? Okay, so you have studied about its curved surface area or total surface area, all these things in your school days. So now here it is important that what are the parameters are here, like you have seen in case of another coordinate systems. So in case of cylindrical coordinate systems, the variables are here rho, phi, and z. These are the three variables. Now we'll see how we are drawing this, and later what we are going to find here, the relation of these cylindrical coordinates in terms of Cartesian coordinates or vice versa. Okay. So now, first of all, we are going to plot here Cartesian coordinate systems. Okay. So for that, you know that we are writing here x, this is the y, and here we have z. Now to understand this cylindrical coordinate system here, so some section, cut section of that we are going to draw here. Okay, so how it is going to look. So now suppose this portion here we have taken, and finally it is coming here. And here you have to make one curve. Okay, so that will see that finally it will going to show the alpha value. Again, in this part, so it will have, you know about the cylinder means it will have same radius. Okay, whatever radius will be there, that will be in form. Now again you make the similar arc here. How is the arc in the bottom? Okay, on this we are going to take some point P. Somewhere this point we are going to take P. The distance of this point P is the rho here. Okay, so that rho is the radius here that we are going to consider. And what will be the height of this cylinder here? That height is what? Z. Now this one, if you'll project here, okay, in XY plane, so it is going to intersect here and will join again this to this point. So this angle is here is phi. So it is also called as the azimuthal plane here. So this XY plane, so this angle is what here? Phi. So this base is the circular in the shape. Okay. And here rho starts with, this is the origin here. So it start with 0. It can have maximum values. Okay. So here range of the rho, what can be the range? Minimum value is what? 0. Is when it is 0 means look like a point. So rho is greater equal to 0 and it is less than infinity. Okay. It can go with very long distance. You can consider very bulky cylinder. Okay. So next another parameter is what? Phi. So this phi value will have, it can be again 0. Okay. And maximum it can be 2 pi or 360 degree. So that is the range of phi. Since it is going to make the circle here. Okay. Again, third parameter is what we are? Z. So Z again, same as the Cartesian coordinates, it is going to be minus infinity to plus infinity. So these are the three parameters and what is the range here. Now, if any vector we are trying to represent in the cylindrical coordinates, so that vector A will be written here as A suffix rho, and this is the again unit vector. And we have A phi, capital A phi, so unit vector A phi again, plus AZ and unit vector AZ. Like this, we are able to write. And if you want to find the magnitude in this case again, so that magnitude we have to write A rho square plus A phi square plus AZ square, and overall square root, so we can write as the exponent 1 by 2. Okay. So this is the discussion about how this cylindrical coordinate representation we have. Now we are going to see how to represent cylindrical coordinates in terms of Cartesian coordinates. So here, if you see that in this diagram here, this row vectors and here angle is phi. If you try to project this one, so x is the cos component, y is the sine component of this. So y is here rho sine phi and x is what? Rho cos phi. So finally here, then what we can write the magnitude of the rho here. Okay. So this is going to be a right angle here. So from this diagram, we'll have rho equal to, okay, root under x square plus y square. This vector is what here? Y. Okay. And here what we have? X. So resultant is what here? Rho. So finally on the basis of that rho we can write root under x square plus y square. Similarly, what can be the phi value? If you apply the tan phi here, so tan phi is what? Y by x. So finally phi will be here tan inverse y by x. Next, what is left? Z. Z is same as the Z value only. Okay. And this is this cylindrical coordinate parameters we have written in terms of Cartesian coordinates. Similarly, this Cartesian coordinates parameters also we can write in terms of cylindrical coordinates. So this x is what here? Rho cos phi. What is the y? Y is the rho sine phi. Okay. And z is what? Same as the z value. Like this, we are able to write these coordinate systems, Cartesian and cylindrical among each other. So finally, we have again discussion about what will be the differential displacement, what will be the differential area, and what is going to be the differential volume. So for that, we have to consider this side of the diagram. So again, if you see that here, okay, differential area is considered here. So this length, how you are finding in case of suppose we have some circle. So in that circle, how we'll find the length of the arc? Okay, this angle is the d phi, and this is your rho. Okay, so this length of the arc is what? Rho d phi. Okay, so since if you talk about the circle, so that is the 2 pi rho is the complete circumference. It is divided by 2 pi. So per unit angle, what is the length of arc? And it is multiplied by the differential angle d phi. So 2 pi is cancelled. So here we are able to get the rho d phi. Okay. So like this, we can have discussion about how we are getting this length of the arc here. So this is the rho d phi. So similarly, differential length of this radius is taken as here d rho. Okay, and this angle is what? Differential angle, that is the dou phi. So finally, on the basis of this, what will be the expression for the differential displacement? So first we are going to write about the differential displacement. Can you write about this expression? Okay, already we have seen the Cartesian one. So can you write here? So here, this again we have similar representation dl. So if you see that differential dimension is what here? D rho. So d rho vector is what here? A rho, unit vector. Plus another length is what we have here? Rho d phi. So rho d phi. Unit vector is what? A phi. Plus, and this vertical is same, z. So that we are writing as the dz. Unit vector is what? Az. So differential is not much difficult. Okay, even the differential area is also not difficult. Just we need to understand properly about this diagram. Okay. So next we have differential area. So area vector will be always perpendicular to the surface. So on the basis of that, you can consider the different situations. So that differential area, if you'll have here, suppose we are going to consider the diagram like this arc, okay? Then you have this vertical length, again this arc is there. So this arc length is rho d phi, okay? And this vertical is what? dz. So this vector area vector will be the radially outwards. That is the A rho. So finally, from here, what we can write for this case again. So what will be the value? So that we are going to write here. Finally, differential area. So that is the, we are going to represent as the ds. Okay. So what we have here, rho d phi, okay, dz, unit vector is what here? A rho. Now if you consider the another situation, okay, so for that, what we are going to get here, d rho d phi, and this vector is the agent, and next situation we have d rho dz, and vector is what? A phi. Like this, we are able to write this values here, okay. So next, what is the last one? Last one, we are talking about the differential volume. So that differential volume, again, what will be the differential volume? This is going to be the product, okay, of all three. So that differential volume here, expression, we have to multiply all these three. So we'll have rho d phi, d rho, and dz. These are the differential volume here, what we are able to find. Okay. So this different situation of the differential area, you can analyze by the help of such type of the diagram. Okay. So here we have to see that what are the ranges here and what is the area vector and differential area, differential displacement and volume. Okay. Thank you.